Okay. Can anybody confirm? Uh, Hello. Can anybody confirm whether I'm audible now?
Yes, sir.
Done. Thank you. Okay. Let's start the session. Sorry for the inconvenience. It's a technical glitch. Um. Okay. So today's session is going to be of three parts. First two parts is of theory, and third one is final one is hands-on session where I'll be showing the uh, how where are the usual data source for oceanographic data through satellite remote sensing, and also I'll be showing how to um, utilize the data and visualize the chlorophyll A pigment, SST, LST, and some of other vegetative indices as well, which are spectral indices. So let's get started on the first session, first part. The outline is basically uh, the applications of remote sensing in fish potential zones through chlorophyll and sea surface temperature. Um, and we'll be seeing the basic theories. So let's get started. So you all know that sustainable goals. Number four is about fisheries and ocean studies. We should be, utilizing all the resources very sustainably, and we have to let our other generations as well to utilize the same. And this slide shows the location of world's famous commercial fisheries and the accumulation of upwelling zones as well along the all over the coast of globes. And here is the mapping fishing grounds using SST and chlorophyll. So by analyzing the SST and chlorophyll concentration from satellite, we can pinpoint productive fishing zones. It means the areas where the fish naturally gather due to favorable condition. So for fish thriving, there are such physiographic conditions to be existed on the water body. So this is not only boasts the fish efficiency but also supports the sustainable marine resource use. So with the tools like Modis, OceanSat, we can turning this vast ocean data into actionable insights for any kind of coastal communities. And here is the basic understanding how SST as an indicator for fish potential zone. So SST is basically the sea surface temperature is the temperature of the ocean upper layer measured by the satellite like Aqua, Terra, like Modis, and it plays a very vital important role in fish behavior. Affecting where they migrate and where they spawn and where they feed as well. So, for example, yellowfin tuna will prefer the warmer water. It's up to like minus. It cannot thrive on lower than like minus 19 degrees Celsius, and some of the fish are really wants to be in the warmer conditions. So by tracking the SST, we can locate the productive fish zones and support the sustainable marine process practices. 1 minute. Okay. Now, understanding chlorophyll as an indicator. So, chlorophyll is also very important key signal for phytoplankton abundance. So, the foundation of the marine food web, we can also call it as that. And using satellite sensors like MODIS and CSAT, like OCM, as I already seen well in the last slide, we can detect the high chlorophyll zones, which often attract fish due to high food availability. So seasonal blooms like algal blooms, upwelling currents, and nutrition inflow make the chlorophyll A dynamic very powerful tool for mapping the productive fish grounds. So it helps us fish smarter, not harder, right? And so modern satellite platforms like Aqua and OceanSat have revolutionary. It has been a very important, significant fisheries mapping technique. So the instruments like MODIS, AMSRE, and OCM capture the sea surface temperature and chlorophyll data with high precision. So by overlaying these data, we can identify the convergence zone and eddies and upwelling regions as well. So these are all the key indicators of fish rich zone. So the tools like the softwares like Satfish and the dashboard like Fish Track help us to visualize these layers in real time. So while GIS platforms allow the spatial analysis and the integration, while vessel tracking and etc. So together these technologies enhance fish efficiency and support the sustainable marine resource and management. So here is the polar orbiting missions, which uses microwave and optical sensors. So all these sensors are very much useful for any kind of oceanographic phenomenal mapping, not just fish potential zone mapping. And here's the challenges. While remote sensing has transformed fish mapping like into very big stream, but it is also have its own challenges as well. So cloud cover. So cloud cover can be a block optical sensor and resolution gap, like the temporal resolution that can also interfere in the real time decision making. But the future looks promising, like when it comes to AI and ML, are very improving and predictive models and integrating the parameters like salinity, current, and bathymetry will refine the fish ground maps. And also, mobile apps and onboard systems are also emerging, bringing the satellite insights directly into the fisherman and promoting the sustainable community driven practices. And here is a case study. So this case study shows how satellite data, especially chlorophyll and SST, can help identifying the productive fishing zone. So it improves catch efficiency, reduce costs, and support sustainable fisheries while also addressing the environmental and eco-political challenges. So from April 2018 to 22, the satellite data on SST and chlorophyll A were mapped for identifying the fishing zones along the Kerala's coast. Using Landsat and MODIS imagery, the authors applied the geospatial and statistical models to identify the areas with low SST and high chlorophyll, ideal for fish aggregation. So these zones were validated with catch data, helping the guide sustainable fishing efforts and reduce cost as well. So over 5 years, satellite data revealed that Kerala's fishing zone have shrunk due to increasing in the sea surface temperature and falling of chlorophyll level. So it is a clear sign of climate impact. So from 2018, conditions were ideal, but by 2022, fish habitats decline. Remote sensing map, like the mapping of due to the remote sensing data, helps us to reduce the search time and cost by up to 70 percentage. It's the result and the conclusion given by these authors. So these are all the results and layouts of each maps they have used for the study. And the bottom right bottom down, the layout shows the weighted overlay analysis for identifying the fish potential zone of Kerala coast. So now we have arrived for the fishery forecast models using remote sensing. So again, SST, chlorophyll, ocean current, and wind patterns, cloud cover, and atmosphere conditions are the very much needed parameters for this. And the proper structure and function of fishery forecast model is the environmental inputs like the parameters that I've told in the last slide, plus salinity, bathymetry, etc. And biological parameters will also plays an important role here. And the techniques that we are going to use is that numerical and statistical model over here, but not with the incentive data, but with the satellite remote sensing based digital numbers. See, output products also, it can be visualized and delivered as the output, where the fisherman can easily access as a dashboard or a website where everybody can access, not just one community or one stakeholder, but it can be useful for many others as well. Yeah, of course, this also have data limitations, species complexity, where we can able to where we can't able to identify the fish species for modeling difficulty, and environmental variability, where the weather pattern changes every day will also influence the accuracy of the model. So here is a case study. So using ARIMA, ARIMA model, researchers have forecasted the India's fish production trend from 1978 to 2027. So it's a future prediction model. So it is a best fit models ever. ARIMA, like 0, 1, 3 are the models, versions of ARIMA for marine, and ARIMA 0, 2, 1 for inlands. So 130 for marine and 120 for inlands predict the steady growth with total production expected to be reach of two, 211 lakh tons by 2026 to 27. So this approach helps the fisheries plan ahead, optimize resources, and tackle past challenges like overexploitation and climate impacts. So it is a very much important product for sustainable use of fisheries and other related products. So here comes the INCOIS, that is Indian National Center for Ocean Information Services. So potential fishing zone advisory, it uses the satellite data on SST and chlorophyll to guide over 7 million coastal fishers across the India. They reduce the search time and fuel cost with maps and text searched via even the mobile apps, radio, television, and local networks, which will boost the sustainable fishing and livelihood. So here comes the monitoring of harmful algal blooms and water quality. So we'll just see how the remote sensing is going to be play its important role in this as well. So harmful algal blooms are the toxins, overgrowth of algae, often called the cyanobacteria. You guys all know that threats the aquatic life, fisheries, and public health. And remote sensing helps monitoring these blooms by tracking the chlorophyll, water clarity, that is turbidity, and temperature, that is SST, enabling the early warning system and better water quality management. So here is the role of RS. So not just chlorophyll, turbidity, SST, but also the microcystin and phycocyanin are the special pigments and toxins associated with cyanobacteria that can be identified by hyperspectral sensors. And applications like we can see US using CYAN, that is Cyanobacteria Assessment Network, and IRS, that is Indian Remote Sensing Center, is using IRS products for fishery management and pollution control. So this case study allows how the satellite data like SST, sea surface height, chlorophyll, and ocean current can predict the tuna catch zone in eastern tropical Pacific. So big eye tuna catch rates were highest near the eddies with warm water and high chlorophyll. So providing the proving like that is the main important zone where we can find high fishing potential. So these results are arrived from remote sensing. That is the main conclusion of the authors, and it can be very much helpful for dynamic fishing strategies and sustainable usage. Yeah, and analysis part that includes big eye tuna catch rates are highest in the eddies, as I already mentioned, with the SST of 26 to 20 degrees Celsius, 28 degrees Celsius with high chlorophyll and a strong current. So satellite data helps us to predict these zones in real time with the high accuracy data. So to be very specific and to put to shout out to all the geologists over there, not just fishing, but there are so many non-living resources on the ocean also exist, like minerals, oil and natural gas, salt, I mean, extracted from the seawater through evaporation, and also desalinated water can be extracted, and methane hydrates and many other renewable resources from littoral currents and tides, waves, etc. So we are at the end of session. Part one. Now we are going to part two. So here we'll be discussing about the ocean currents and circulation, upwelling zones. So upwelling zones are the very important, zones where the fish catch will be more, and climate monitoring and the environmental hazards. How the remote sensing is going to be playing is very important role in that as well. So let's just skip the introduction for now. And yes, oceanographic application, and it's a general introduction, like we already know SST, ocean circulation, studying large cycle circulation eddies and transportation pathway, ocean productivity assessment, that is not just for fishing but also for primary productivity, phytoplankton's growth, and it also an indirect indicator for water quality as well. And we can able to monitor and model the climate and weather patterns, and we can able to forecast and broadcast it. And coral, the studies related to coral reef, environmental hazard detection, coastal zone management, and of course fishery application. And here is a depiction of ocean application of satellite remote sensing. It's all about the sensors and the parameters which has been useful for oceanographic phenomenal studies. Ocean currents. Ocean currents are continuous movement of seawater driven by wind, temperature, salinity, and Earth's rotation. So they transport nutrients, regulate climate, and support marine ecosystem through surface and deep water flows. So surface currents are driven by the wind, are called Coriolis effect, while the deep current follow temperature and salinity differences, called thermocline circulation. So this global conveyor belt moves nutrients and heat as well, shaping the marine ecosystem and climate. So thermocline circulation is the ocean global conveyor belt, driven by the temperature and salinity difference. Warm surface water sinks in the cold region, flow deeps across the basin, and upwells as well. So mixing of nutrients and regulation of the climate all over the world is by through this circulation only. Remote sensing uh, maps the ocean current using satellite altimetry, scatterometer, radiometer, and ocean color sensors. So these tools help to track the eddies, upwelling zones, and map the circulation pattern, which is very crucial for climate modeling, fisheries, and maritime safety, and navigation as well. And here is the application and importance. Of course, climate and weather prediction and environmental monitoring, and it is very much useful for extensive and advanced oceanographic researchers. Now, upwelling zones and productivity. Actually, upwelling brings the cold, nutrition-rich water to the surface, and fueling the it is the main driven force for phytoplankton growth. So this boosts the marine productivity, supporting the fish, zooplankton, and rich ecosystem of that water body. So this is the key zone for sustainable fishing. So types of upwelling, you all guys know: coastal upwelling, equatorial upwelling, and oceanic or eddy upwelling. So remote sensing indicators here also, SST, ocean color sensors like MODIS, CWIPS, and OCM, and altimetry, that is the sea surface height. And also the productivity and application comes under everything is like the same, but here the climate links and carbon cycle is also an important additional parameters that we can able to apply on this uh, upwelling zones. Here comes the climate monitoring. So climate monitoring, the ocean regulates the all these climatic actions, everything. But the remote sensing helps to monitor the patterns like ENSO. ENSO is nothing but El Nino Southern Oscillation, monsoon, and coral bleaching as well. So it offers the long term insights into climate variability and ocean atmosphere interactions. So ENSO is a climate cycle in the Pacific that affects the global weather every 2 to 7 years. So El Nino brings the warmer water and droughts, while La Nina cools the ocean and strengthens the monsoon. So neutral means normal condition. Remote sensing helps to monitor these phases for better climate forecasting. And these patterns shift every 2 to 7 years, as I already mentioned, disrupting this large scale flow of air in the tropic regions that triggers the cascade of global side effects. So here is the role of remote sensing for SST, AVHRR, MODIS, VIRS, AMSRE, and for SSH, Topux, and other Sentinel 6 is also a very important sensor to capture the SSH. And ocean color, we all know. And we have QuickScat and ASCAT for surface wind and atmospheric coupling sensor. And for we have IMD for rainfall and precipitation data. And we have the application of remote sensing in this. Of course, we can do the early warning system, monsoon forecasting, disaster preparedness, fisheries, and climate models. And yes, India contributes to the climate crisis, says this particular study, where India is the one of the biggest, contributors for this rise in the global warming. Just to note. And here is the application of RS in the study. Onset prediction, seasonal forecasting, extreme event monitoring, marine productivity, and etc. Here is a coral bleaching. So coral bleaching happens when rising sea temperature and stress causes the corals to expel algae, losing their color and life. So it triggers includes like even the heat, plus or minus 1 or 2 degrees Celsius, and UV radiation, acidification, and pollution. So these are all the threatening parameters for algal blooms. Without algae, coral weakens and it may die. So it is the threatening of marine ecosystem, and it is also an important parameter for health of the marine ecosystem. So here the role of remote sensing is like ocean color we can see, and turbidity we can see how the water clarity through the satellite sensors. And using hyperspectral remote sensing, we can able to identify it with very minute spectral signatures. And we can use the synthetic radar aperture and lidar as well, laser beam technologies, to monitor this coral bleaching. So here is the coral bleaching stress, heat stress map. And here comes the environmental hazards. Ocean face rising threats of human activity and climate change. You all know, like oil spills, erosion, and habitat loss, etc. So remote sensing, we'll see how remote sensing is going to useful here. So using radar and infrared radiation and UV sensor, it supports remote sensing supports the law enforcement and protects the coastal habitats. So it is very important thing to make policies over oil spill. And remote sensing plays an important role for covering the whole synoptic and holistic approach for any kind of these policy regulations, etc. So here are the basic sensors. If we are going to use the SAR, synthetic aperture radar, the sensors are Sentinel-1, RadarSat, TerraSAR X, RISAT. And if you're going to use the optical remote sensing, like visible and near infrared, the sensors like satellites OLI and Landsat's OLI, Sentinel 2's MSI, and MODIS, Aqua and Terra both. And if you're going to use the thermal infrared, MODIS, Aster, AVHRR are very useful. If you're going to use microwave radars, there are many options, like we can use the C band, L band, and X band of synthetic radar aperture. And AVERS, NMAP, Prisma are the remote sensing sensor, hyperspectral remote sensing sensors that provides data for coral bleach mapping. Oil spill monitoring. So here are the few applications of remote sensing on oil spill monitoring. And here comes the coastal erosion. So it is the loss of shoreline caused by the wave, tide, storms, sea level rise, and human activities like construction and sand mining. It leads to land loss, habitat damage, and threats to fisheries and livelihood. So we'll see how what all the remote sensing sensors are very useful here. For optical remote sensing, Landsat like MSS multispectral sensors, TM thematic mapper, OLI ocean land imager, and Sentinel 2 is multispectral imagery, and Iconos, it is very important parameter for coral reef bleaching as well. The sensors, it captures the high precision data for it, and it can be useful for coastal erosion monitoring as well. So worldview, planet scope. So these are all optical sensors, like visible to near infrared. And for altimetry, Topex and JSON Sentinel 6. If you're going to use SAR data, Sentinel 1, RadarSat, RISAT, TerraSAR-X, etc. And lasers are also very useful, where if you're going to do it in for small area, using these laser beams, we can able to acquire the high precision data. So here is the habitat loss. Ocean actually Ocean habitat loss refers to the degradation of marine ecosystems such as mangroves, coral reefs, seabed grass, estuaries, etc. So the questions that have been put out on the yesterday's session will be answered in few slides. So habitat loss affects the mangroves and other critical coastal habitat caused by climatic change, pollution, overfishing, and coastal development. So it leads to biodiversity loss, weaker fisheries, and a threat to coastal livelihood. We'll see how the remote sensing is going to be useful here. So it is the this picture depicts the habitat loss in marine ecosystem. So for mangrove, the data will be from, if we are going to choose the Landsat satellite, MSS, TM, OLI. If it is Sentinel 2, MSI, um, and we can use Spot, we can use Worldview, PlanetScope. For seagrass, we can use any kind of optical sensor, optical remote sensing reflectance from Landsat data, Sentinel-2 data, and MODIS. So MODIS is for especially remote sensing reflectance as the proxy of turbidity. It's not a direct indicator of turbidity. The water clarity is being derived, or it can be the proxy model which is being derived from remote sensing reflectance of particular nanometer. And chlorophyll as well we can use from MODIS, hyperspectral sensors for high precision data, and coastal wetlands and estuaries can also be monitored by SAR data from Sentinel 1. Sentinel 2 can also be useful. Sentinel 3 is also useful, also added as a Spot as a very important and high precision data for coastal wetlands and estuaries mapping. So the applications over here, we can see that everything is same. The extra is carbon accounting. where the estimation of blue carbon stock in mangroves and seagrass is important application of remote sensing in ocean habitat loss monitoring. So yeah, that's all for the theory part. Let's move on to the practical session, like hands-on, where we can see that I'll just uh, get you guys to the Copernicus Hub Sentinel. It is the data hub for accessing the Sentinel data, and we can download the data from it, and the basic visualization will be done on Google Earth Engine. So we'll be doing the chlorophyll and SST and some of other parameters as well, like enhanced vegetation indices and remote environmental change indicators as well. So let's just skip to that part. I think I stopped sharing the screen. Uh, you guys can see the screen. Hello, please somebody confirm whether you can see my screen. I've opened the browser of Copernicus website. Can you all see that?
That's fair.
Done. Thank you. Okay. I hope you guys are having the laptop with you. If not, it's not a problem. Um, I'll just share the link where you can, go to this Copernicus Hub website. Okay. So the link is in chat box. For Sentinel data, the first link, and for accessing the Google Earth Engine interface, the second link. So for now, all of you, please just click on to the first link that I have shared in the chat box. So we are going to access the Sentinel-3 data. Okay. Shall I proceed? Somebody confirm. Shall I proceed?
Yes, yes.
Okay. So after clicking the first link that I've been shared in the chat box, you'll get this interface. this site. So through this website, we can access the Sentinel-3 data, where it will comprise of all the oceanographic remote sensing parameters. Um, okay, so you need to actually create an account to access the remote sensing data in this website. It's just few step, like it will take your name, email address, and some of the reasons why you need this website, like you can give research or on own interest you can give. So then you may able to create your own account to access any kind of data from this website. So I have already created the account for me. So I'm just going to visualize a data or a scene, a satellite scene for I can't say the whole Kerala coast. I may say the coastal district of coastal taluks of Ernakulam and Alapi. Okay, so here is the two segments. Over here it is visualize, and here is a search. So in visualize part, you can see that the date, you can visualize a single date. You can by clicking from here, you may able to know which are the dates that we can able to observe from here. You can see the cloud cover, and there are so much of different types of parameters like NDVI, false color to identify the urban area, moisture index, true color, false color, NDWI, that is normalized different water index, normalized different soil index. Um like we have so much of layers over here, but for now, we are going to search a particular data product from this website. So I am going to draw a polygon, draw a box of my study area or the area of interest where my research is going to be. Okay, so this the second box, you can see that create an area of interest. So on that, draw rectangle area of interest for image downloads and time lapse. So click this box and click another one point on the screen where you want to create a start your box, and another click to finish that box. So now you got the rectangular shape or any kind of shape that you drawn, technically your area of interest. Okay, so this is your area of interest. This is our area of interest, and here are these search criteria. So here, data sources, we can able to see so much of Sentinel missions over here. In this, we can explore. You can actually explore in Sentinel-1. We are having so much of levels, that is raw, it is enhanced data with all. So all these level 1 and level 2 are the corrected, atmospherically corrected data. If you're really wants the real digital numbers that has been extracted by the sensors, it is called raw data, that is level 0 data. Or if you want the atmospherically corrected data, geometrically corrected data, radiometrically corrected data, you can go for level 1 and level 2. In the same case for Sentinel 2 as well. So MSI is nothing but multispectral imager. It is the sensor that has been used by the satellite, sorry, Sentinel 2. So Sentinel 2 is the platform, MSI is the sensor. So we can able to observe the difference between platform and sensor that I have told yesterday. So here also we can observe LC1, L1C and L2A. So these also different level of data. This is the level 1 and level 2 of MSI of Sentinel-2 satellite. Now here comes the hero, Sentinel-3. So Sentinel-3, we have this OLCI. All these you can see, no? I just let me just give you the small, what are these important parameters that has been detected by Sentinel-3. So first one is OLCI, that is called Ocean and Land Color Instrument. So it is the multispectral sensor on Sentinel-3. Um, it is mainly used for monitoring the ocean color, chlorophyll, and coastal water quality. Um, then we have the level 1. You can see um, EFR, ERR. Like these are also like, let me just read out a few names. EFR, that is full resolution, ERR, that is reduced resolution, LFR, that is full resolution and land product, LRR, that is reduced resolution land product. And we have this SRAL, that is synthetic aperture radar altimeter, to retrieve the data of sea surface height, and it also established the bathymetry data as well. And we have SLSTR, that is called sea and land surface temperature radiometer. So from this we can able to retrieve the SST data. And we have synergy data. Synergy products is combines of OLCI and SST. So synergy is the product where we can use directly for fish potential zone, where it combines the chlorophyll A pigment and SST. So we can able to easily able to zone the potential area for fishing. Then we have complementary and ancillary. So these are all the files where we can able to find the details of all the above said sensors, and what are all the product details, what are all the resolution, what is the aerial coverage, what is the details of digital numbers, what is a unit that has been recorded, and what will be the proper color coding visualization pattern when we are literally plotting those digital numbers. So all these details will be given in complementary and ancillary data file. So for now, let's um, just a minute. Ah, okay. So for now, let's just give OLCI. So in OLCI, you may able to see all these level 1, level 2. As I already briefed out all these full forms. So you can choose how much you want. So you can choose all a synergy as well. In synergy also there are different levels. You can see different details. You can see AOD data, and we can also click SLSTR. So it includes LST. LST is land surface temperature. Technically, there is no much difference between land surface temperature and sea surface temperature. Only it's the landforms where we are actually concentrating. For sensor and satellite, the Earth surface is Earth surface. Whether it is land or ocean, for it's the same only. But the reflectance and signature spectral signatures are different, because the land part will have a different reflectance range, and sea part will have different reflectance range, because don't know, I mean, both are different, right? Water have a different irradiance, and the land part, like where plants, vegetation, buildings have different irradiance level. So you can click as much as products you want and click on to the search, and you can give the date ranges as well, where you can see, let me just give January 2025 to August 1st of 2025. Let's just wait until the scenes are exhibited. I think we'll just since we have given lots of parameters, it's taking lots of time to load. So yeah, to show you clearly, let me just alter the products that we have chosen. Let's just give one product at a time. Okay, let's just stick on to OLCI and give search. And you can see the area of our polygon or the area of interest that we have created on the side. So yeah, you can see the scene. So it's all over this. If you want to visualize it, we can actually. So by just clicking onto the visualization part, we'll skip to the visualization part over here, and you can see the different ranges of integrated water vapor. It's well exhibited in the Manarkudi region of Tamil Nadu, and it is well exhibited up to Park Strait and Park Bay. At I think it's up to Trivandrum. It is okay. So why we can see the data it is missing over here on the west coast. It's because of the cloud cover. So the Western Ghats, it's densely packed with trees, so automatically it exhibits high cloud cover over here. And here also in Tamil Nadu we can see some of the cloud covers where the data is missing. So this is how. So if you want to download that data, you can click this download product. So after that we'll able to actually see what are all the data, what are all the product and instruments used, platforms used. And if you want to download it as a single file, you can download, or if you want to download as each files or each segmented fragmented files, you can also do that. You just click download, you will get your file in your file manager of your PC. So it's that easy to download the Sentinel-2 data from here. Now I think we'll just move on to Google Earth Engine. Google Earth Engine part, yeah. I don't know how many of you are exposed with this Google Earth Engine. So Google Earth Engine, it's basically the code editor, the coding, coding of uh, the practices that we are traditionally or conventionally doing in the labs and in other softwares like ArcGIS, QGIS, Snap, Ocean Data View, CDAS, etc. So all the softwares that I told now, mentioned now, it's those are the visualization or the analytical software where we can use both land and oceanographic applications, especially CDAS, Ocean Data View, Snap, and all. It is very useful for oceanographic plotting. So instead of doing that by clicking all those inputs, outputs, analyzing, model making, everything, here we are just going to type everything and we are going to click the run button and everything will happen on fraction of seconds. So here let me just give you the brief introduction, like brief overview of what I have written in this code. So I have so much of codes that has been. So to explain the interface, I have an account over here on my name, and scripts are the basic files or the Google Earth Engine scripts that have been saved earlier. These are all my earlier projects, and documents are just uh, the algorithms or the scripts or the libraries. Libraries are nothing but the data codes that has been already inputted or implemented or stored in a particular packet. So that packet is called libraries. So those libraries are assigned and aligned over here in the document session. And assets, so asset are nothing but the shape files, basically the files, spatial files that we are uploading it to the Google Earth Engine. So these are all the scripts that I have created in the Google Earth Engine. So these are all the these are all the libraries that already built in the Google Earth Engine. These are all the assets where we are inputting from our file to Google Earth Engine. So that's the basic difference of these three segments. And inspector will give the brief. If we are running the code, the error will be popped up in instructor. And console is the chart creator or the instant data analytical graphs we can able to see over in the uh, console part. And in task, if you want to download that particular layer into your system, we can download from this you know tasks. So in that task we can see everything is, if we are, if just I'm going to run this, the chlorophyll index of 2020 of Kerala coast will be downloaded in Google Drive, where the same drive, the same mail ID that has been logged into Google Earth Engine. So it's just need your Google account, Gmail account. So that Gmail account will open, and the same like what is the purpose of Google Earth Engine, it will ask. You will just give research purpose. You will get the Google Earth Engine account. Then you can able to access this website. So this site address I have been posted in the chat box. So let's just get started with the coding. So I drawn a box, a steady area over the Ernakulam, Kochi city. It covers minimum of land part and minimum of backwater Kayal and maximum of the sea area. I don't know how this sea is going to exhibit the satellite data, because sea surface, when we are going towards the sea, the parameters will get declined, because as we are entering into the deep ocean, the surface temperature only will get exhibited. Chlorophyll and other CDOM will all be depleted on the deep sea. Only in the coast and backwater we can see. Let's try. Okay, so I have drawn the box. Those box coordinates is called geometry. It has four vertices, so that is exhibited here. And for monitoring, in this particular code we will be monitoring the chlorophyll A and vegetative index through using the sentinel 2A. So the aerial extent of this particular box is exhibited in the coordinates x and y. You all know that, I guess. In spatial data, everything is x and y, latitude and longitude. And the region of interest that is called ROI, I just give the scale of 12, where the zooming level, it will differ. If you give small number, it will zoom out, and if you give larger number, it will zoom in. And the date variation from 2017 to 2024 I've given. And to call out the sentinel 2A, so in the Copernicus we are selecting, giving the date, selecting the area by box, and we are giving the parameters, like what are all the parameters, what are all the products we need by clicks. Whereas in Google Earth Engine, we are giving by codes, means letters form. That is the only difference. But here the biggest advantage of Google Earth Engine is that we can analyze and we can, give the time series analysis. We can, visualize each and every product then and there. Where in the Copernicus we need to download it, it will take time, and we need another external software or application to visualize or analyze that. So in but Google Earth Engine is a single window where we can access the data, visualize the data, and analyze the data. So that is the power of Google Earth Engine over here. And we are giving the cloud cover range. So there are some, we have spectral indices in remote sensing where there are so many spectral indices: NDVI, NDWI, NDBI, NDWBI. So these are all the normalized differential spectral indices to, exhibit or visualize different earth products. So here we are going to visualize the vegetation part that actually going to reveal the chlorophyll content for us. And the NDVI is, as I already mentioned, normalized difference vegetative index. EVI is enhanced vegetation index. RECI is remote environmental change indicator. So we are going to visualize each and everything by the band combination. So in one sensor, we have so many bands: band 1, band 2, band 3, band 4. So each band have remote sensing reflectance of a specific electromagnetic spectrum with a specific nanometer or micrometer of that wavelength. So that is the spectral indicator that we can use those each data for each indicators. Like if you are going to use it as a SST, if you are going to use it as a chlorophyll, etc. So we can, from 2014, I think 2014, right? 2017, sorry, 2017 to 2024, I'm going to create a time series analysis. So what is the level? It is increasing or decreasing of that range of these parameters. And I'm going to visualize these parameters in Google Earth Engine itself. And if I want to add that layer into this map, I mean, the map you can see over here, if that map, this code is going to be helpful. And if you're going to export it to your drive, Google Drive, this is the code that to exhibit that. For each layer, each set of code you need to give for each layer, and then just give run. If you run, see, it automatically zoomed into a particular range of Kochi city or the backwater of Ernakulam region. So yeah, let's just visualize each and everything. So this is a steady area that we have created. Let's just off that product. And now we are going to visualize the NDVI for 2020. See, normalized vegetation, normalized difference vegetation. You can see how the variation it's happening over here. So the vegetation index, it is low if it is indicated in red color, and it is green color if it is of more vegetation. So you can see the region, the part over here. The cursor is moving, like I think it is Vipin region or Valap region. So these are all the regions where we can see that pine trees and some mangroves as well. So I think in Kerala, Kannur and Ernakulam are the most highest mangroves exhibiting regions. As I'm working in Forest Survey of India, I can be sure about that detail, where these mangroves are high in in these regions, and some of the other vegetation species also exhibiting these green color. Let's just move on to chlorophyll data, chlorophyll indices of 2020. Yes, The vegetation index, if it is showing high, obviously the data with chlorophyll is also high. It is then we can visualize EVI. EVI is nothing but enhanced vegetation index. You can see the that spots of yellow and orangish red shade over the water body. That is called enhanced vegetation index. It is the indirect indicator of phytoplankton, or we can say uh, chlorophyll A pigment. Not just chlorophyll A, chlorophyll B as well. Okay. Now RECI. RECA is nothing but environmental change indicator. So where the change is really happening, that will be obviously on the the part near to the uh, city, the urban part, or we can say the places over here. I think it is to be area specific. It is around the Fort Kochi and the region of Tevra, etc. So these regions shows the highest exhibition of high variation. Okay, so through this we can able to identify the differential range of these parameters. Now come to the console part where we can see the time series analysis of all these parameters. You can see uh, the sharp decline of EVI over here, this part, and the sharp decline over here as well. So it is just the minus part, and the topmost part that we are seeing is from here. And to be interesting, in my last research where I have studied correlated the climate change and urban flood over Kochi region, along with the urbanization dynamics, I have received the very lowest point on during 2018. So when going through the scripts and when I'm going through the literature review of many literatures and articles, that's due to the 2018 flooding event. That is a mass event all over the Kerala, I guess. So that is the reason why I got that sharp negative point for all my parameters. Let me just show you that. Uh, yeah, in that I'll get, yeah, here it is. So yeah, that script is over now. So let's just move on to the next script. So it is for LST, or we can say the SST as well, sea surface temperature, and NDVI. So you can see the time series analysis over here, the sharp decline over the end of 2017 and early 2018, or the monsoon season of 2018, sorry. So those SST and LST, it's all because of the cloud cover during that cloud burst happening. So this is the time series that we can see on the console part. And to explain this code, I have derived all the parameters from Landsat 8 data. So it is both helpful for oceanographic and land part as well. Everything others are same. I have given the NDVI 2020 pre-monsoon, post-monsoon. You can also apply this for LST as well, SST as well. For pre-monsoon, post-monsoon analysis of both time series and visualization, we can do that. And we have so many layers to visualize over here. Let's just see one by one. So it is the steady area, and it is the true color composite where you can see the exact Google Earth terrain view from satellite. So if you enhance these data, like just give the settings over here, and there are some stretch levels over here. So you can change the band 3, band 2, and band 4 are the combinations for this true color composite. True color composite is nothing but the true color of the earth. False color composite, it's we are going to manipulate any of these one date band, and we are going to enhance or highlight those features that we are interested in. If you are going to study the vegetation and urban area, false color composite with band 8432, it's excellent for it. And for others it will vary. So we have stretch level over here, stretch 1, stretch 2, 3, 90%, 98%, 100%. So if you're going to choose any one of this, you can explore and how the false color composite is changing according to each stretch level change. It is a false color composite. As I said already, you can see all these red color are the chlorophyll content or the vegetation area. This is the LST and the SST of 2020 pre-monsoon, and this is of sea surface temperature post-monsoon, right? So if you want to know the exact numbers, you can download from the task over here. So all these parameters have been, you know, uh, ready to run, and it will be saved after the click of run to your Google Drive. Let's just visualize pre-monsoon NDVI, and this is post-monsoon NDVI. Any questions? Hello?
Classy, beautiful, trending colors.
The session is open to questions and queries. If you want to clarify something, you can ask. If you want to know about, or if you want to add some points towards the presentation, some suggestions you can give to improve the presentation, anything is welcomed.
Hello?
Yes, Google it. Yes, I'm getting some questions in the chat box. Is Google Earth Pro and Google Earth Engine is the same? No. Google Earth Pro is this. It's a software. Google Earth Pro is a software where we can see the time series of different types of terrain view, satellite view of the landform. Whereas Google Earth Engine is a website where we can access the satellite data. In this Google Earth Pro, we cannot access the satellite data. We can just only see the visualize the landforms. We can use the time series over here. Click the time series, and we can visualize the data from 1984 to 2025 present. I think it's not real time. 2025 it is not available. I think up to 2023, early 2023, up to March or February of 2023, it's available on Google Earth Pro. But Google Earth Engine is the real time data capture of every satellite that we can code and visualize and analysis everything. Where do we get the codes of Google Earth Engine? Okay. Agalya Balan, it's very much interested, I guess. To answer your question, Google Earth Engine's code has to be, uh, you know, written by a coder. So, as a remote sensing analyst or GIS specialist, I can write the code, but as oceanographic person, or the science background persons can actually can take the help of remote sensing analyst directly, I can say. And you can just give the idea how these oceanographic parameters involving interacting towards it, the scientific reason can be given by your side, and the GIS and remote sensing analyst will write the code for you. That is the only thing. Or if you want to learn, the scripts are readily available in Google Earth Engine itself. So type Google, just GEE catalog. I think somebody is enjoying some ad films. Please unmute yourself. Google Earth Engine data catalog. So this is the website where you can explore so much of codes for variety of applications, not just for oceanography, not just for fishery activity. You can able to identify many data sets like as see a surface temperature, climate. So you can have the code from here. API docs. There are many all data sets here, all tags here, Landsat, Modis, Sentinel. So these data sets can be accessed from here. How to download the ocean current data? So current data can be downloaded like AVHRR, VIRS data. So these data are highly precise data, and some of the data are not open for all of us for the civil use. It is highly paid. We can, if your institution is funded, if the project is funded, we can able to pay for it, and we can afford the data. Otherwise, we can use thermal infrared data from open source sensors. So through the we can make the alternative of usage of thermal infrared sensors. Generally, how many year gaps Google is updating? Okay, so actually Google Maps are um, taking survey every year, but the release of the data is the main problem, because they need to get rid of all the cloud cover, get rid of all the, but it is not some, you can see still you can see some of the clouds in the Google Earth Pro images. Yeah, but some of the images has to be mosaic, like it is the the data capturing, it's very easy, but the data will be visualized, and when it is in the releasing format, it has to be mosaiced, all these tiles, all these scenes, scene by scene mosaicing or merging, corrections of atmospheric error, geometric error, radiometric error, all has to be done before releasing. So that post processing, pre processing of that data will take time for us. So every year they are taking surveying, but I think 2 years once they are updating their image. How hyperspectral imaging be optimized to differentiate between the phytoplankton community and harmful algal blooms in shrimps and fish ponds at sub-meter spatial resolution? Okay, so hyperspectral imaging, as I think you know about hyperspectral sensors, it is very much precise. If you have 7 to 8 bands in Landsat data, if you have 10 to 20 bands in Sentinel, you will be having 250 to 300 bands in hyperspectral remote sensing. So one band is indicating chlorophyll in Sentinel and Landsat, but 5 different bands to 10 different bands will be indicated the same chlorophyll parameter in hyperspectral sensor. So it is very highly precise. Of course, it can be useful for up to certain level to differentiate the planktonic community and harmful algal blooms, which are toxic and which are non-toxic. But only few toxic elements can be analyzed from hyperspectral remote sensing, because you guys are directly going to the field and taking the samples and analyzing in the lab, and coming up with the statistical analysis of those. and we can extrapolate the data. I mean, I hope you're known about the terminologies interpolation and extrapolation. By the point, you can, summarize that all the surrounding buffer or the same value or with same value. So that is called extrapolation. So you guys are doing all these things, but somewhere, with some altitude, the satellite remote sensing can only do its level best at some level. It cannot, differentiate all the toxin, harmful algal blooms as it is. Python programming will be useful for coding, right? Yes, Python programming is very much useful, but in Google Earth Engine, mainly the JavaScripts is very useful. Java language, JavaScript is mainly very much useful in the Google Earth Engine, but Python is the upcoming programming language where we can use it in the Jupyter Notebook, Google Colab, and other machine learning APIs as well. I think for all the AI and ML, Python is more useful. But if we are considering Google Earth Engine, JavaScripts are very much useful. How to measure mean sea level through remote sensing? We have sea surface height that I already shown in the Sentinel 3. So one of those parameters, one of those sensors is mapping this sea surface height, and we can also exhibit bathymetry. How do I mask clouds in Sentinel 2 imagery using QA band? Naina, please add some more details on QA band. But cloud masking, it is very easy in Google Earth Engine. You just give the cloud percentage, how much cloud cover can be existed in your scene, in your analysis area, that you can determine by giving just one number. If it is 0.1, it is very minimal. If it is 1, it is minimal up to certain level. If it is 5, 10, it is level. So if the data is really not available on your particular study research area, period or research area, you can actually increase the cloud level. So if it is 5% cloud coverage, you can actually get 10 to 15 datas in place of one data or two data. So it will increase the chances of getting the more scenes, which is very apt for covering both sea and land as well. So cloud covering is an important parameter in assessing the data from online. How to capture data from inland backwater current as it is done for ocean current? How to capture the data from inland backwater current as it is done by water? Okay, so actually inland currents are very dynamic when it is compared to ocean currents. I know, like ocean is very big area, land is very small area comparatively, but the influencing parameter, anthropogenic activity, all the human and the influence of the inland currents are very much high. So the precision will be low, the data acquisition will also be very low. Whereas the ocean current, we have the pattern, we have the historical data from 90s, so we can able to give the trend how it is going to be, and we can also able to give the future prediction. So from that future prediction, we can correct the statistical numbers of this current observation, and we can come up with the answer for ocean current. But in inland current, it is not the same case. It will be very hard because the influencing parameters is very high. How to capture? Okay, could you please share the script you used to demonstrate the data? Could you guide me on the Rajeshwari Gowda? Of course, I will share the script to you. Um, like you can, I don't know, I can give the second script because it's under research on my, it's a part of my research. it is not it's still on the process. The coding is not finalized. So but I can give the first script where it is open only. So I can share you the first script to all of you guys. You just explore first. If you're not having the Google Earth Engine account, please open it. It is a very simple step, very easy to get it. So you can explore a lot more in accessing the satellite data. I'll guide, obviously. Okay. Basically, tidal flows. What is tidal flows? Joe, what you're trying to say? Basically, tidal flows. I'm happy with all these questions. Is there any more questions I can tackle? How can we find the location which destroyed by man intervention in a river through these technology? Okay, riverine process. So of course, the same story. Riverine processes are highly dynamic, right? The inland flows, the infiltration, the precipitation flow, everything it is highly complex and dynamics. The flooding event, for example, if I just want to give you an example of flooding, there are two types of flooding. One is riverine flooding, that is due to high rainfall. Flash flood, that is due to heavy rainfall in a particular specific area. And we have coastal floods. Coastal floods is mainly due to the tidal and wave action and the sea level rise, which is very much easy to establish and very much easy to forecast. But whereas this precipitation, flash flood, inland floods are very much complex to identify and forecast. The forewarning system are very much in a very primitive level when in the accordance of inland floods. So this human interventions, we can actually study the environmental impact assessment. There is one famous popular study that uses the remote sensing data and GIS technology, like how the human influence, like if one industry is there, it is releasing the effluent to the water body or to the bare land, how the agriculture is land is being depleted and the wasteland is being converted into urban land. So all these land use land cover change along with the riverine inflow infiltration and that volumetric analysis of that particular river water body, that we also so the comparative study we can see, and we can conclude how the human activities are classified being the primitive reason for that riverine changes. We can, of course,
Yes,
it's
sir.
possible through remote sensing and GIS technology.
Hello.
Hello, yes.
Yes, sir. Am I audible?
Yes, sir.
Yes, sir. Very good evening. Actually, I typed this question because I want to go the precise the part through particular question. Actually, I'm research on a species which is endangered. Actually, it is endangered to being after the some anthropogenic activities like the specific. I will going to assign mining. So I would like to trace the location in the river, which is the very large river in particular state MP, Madhya Pradesh. So I would like to find out the reason where the human mining maximum for sand and the area that will be an area of the breeding ground, particular for the species of tortoise. I'm talking about that. So how can we find out, or how can we look? How can we see with the help of this software or other softwares?
Okay. Good evening. Actually, now I'm getting what is your real question is. Thank you for the explanation. Yes, sand mining, it's highly related to erosion, coastal erosion. It can directly related to that parameter, I guess. So up to my knowledge, the sedimentary inflow, because the sand mining, if it is happening on that particular area, the volumetric load of sand and volumetric load of river inflow to that water body will change. That dynamics we can establish. Of course, it will require some research paper, but through Landsat, Sentinel, and OceanSat OCM. So these are all the three important open source data where we can observe the land dynamics and river inflow dynamics. Of course, you will be needing the corporations uh, water board infiltration rate, that those statistical analysis that is highly required. But through remote sensing we can analyze on the larger regional plots, like for the larger area, how these SSTs influencing there, and how the chlorophyll content is being changed over there, that region we can analyze, and we can support the result that you are coming up with from your research. I think that is my answer is convinced for you. If
Yes,
anything
yes,
else,
sir. I
you
can
can add.
understand it. Means does I mean to have I have require a more a large area. It is not workful. It is not the functional for me as such kind of a short area, as such. For example, I want to find out the location the river, so it is not useful for in river particular.
Oh, may I ask, like, what is your, study area or the region of interest you're working on?
Actually, I'm a conservationist. I'm conserving endangered species, which is one of my state fish, Mahashi turtle.
No,
I'm
no.
working on
I'm
that. The
asking
last
the geographical location. Which area you're working means the which town or city, the that area.
Jabalpur, Jabalpur in Madhya Pradesh.
Okay, Jabalpur in MP. Okay, you are taking the whole study area. That is that a taluk? Is that a district?
No, actually, the area is where the river is flowing there. I'm working the region where a fish is going on or the highly abundant or it finds something in this area. Only the zone is selected as a research site.
Okay, then if that river is first, we should know that seasonal condition, whether it is ephemeral river or perennial river, and we can, if you are restricted to that small area, we
It's a
can go for
perennial.
in situ. Okay, if it is perennial, so if you can go for in situ observation as well, where you can get the seasonal data and sediment level, how much nutrients it's carrying, and the water quality as well. So that data will be supported by the satellite data. I think that will be a good combo of both the in situ and satellite remote sensing results. So then that the result of your research will be like, it is very complementary, and it is very much reliable for further studies.
Yes, sir. Actually, if I want to move you on my particular topic, that what I want to do right now, because the as the me things as the conservation or the cryopreservation of the milk, the particular species I have done in my masters. So now I am pursuing my PhD for the special reason of this because I want to conserve this species. I'm a PhD
Okay.
scholar from SOCAST, Kashmir. So now I'm starting. It is the initial. It is the first time of the world because I want to cryopreserve the egg of the particular species. So the reason behind I want to join this program because I want to find out something a pin like things in a sea. Such thing I want to find out the good brooders of female or the male from this particular species in the river. The river is too much large. How can I go the particular location for the find out this species or the associated place of this species?
Okay. So where that, okay. So in the question he's asking is that I'm talking about all the ocean, the sea level, but he wants to be specific particular geographical location in that particular river, right? Where in ocean, the upwelling zones, the eddy currents, the low SST high chlorophyll is the high potential fishing zone. But in river, you're asking, right?
Yes, sir. Yes.
Yeah, actually, in riverine process, it's highly dynamic. That's what I'm saying. So it is not the same as oceanographic phenomena, right? But
Yes,
if
I
that
was told you. Yes, means this application is not useful for the.
yeah, the because the data from satellite is for the large scale, not just for single river. It's for the bigger geographical location. So if that's what that's why I asked whether it is a particular taluk or particular district of MP. So if it is a taluk or district level, or if it is for a whole state, we can obviously establish that all these parameters through satellite data. The only thing you can do now is that you can go for incentive data, or if you are really funded for these the research you're going on, then you can go for laser. Then you can go for hyperspectral sensors hybrided in any kind of UAVs. You can do that. There is a VTOL, where the vertical takeoff and landing, that is a type of drone, VTOL drone. You can you can deploy that, and you can get the remote hyperspectral sensor, and you can fix that. You can try the testing over there, and you can fly all over the river, which the study area has been extended. Then you can take the spectral indices of those chlorophyll, turbidity, and other parameter SST. So all these are captured from the sensor, and you can analyze these data in softwares. The software can be RGIS, QGIS mainly. RGIS is licensed, but the open source is QGIS. And you have another specific software, that is NV. Please note it down: NV, ENVI. This NV software, it is very much useful for
Pardon, sir. Please pardon.
NV, sorry, ENVI, NV. It is a software where we can analyze and decode the spectral indices from the hyperspectral sensor. Other all sensors are in different formats, that is in big geotiff or SHP, whether it is vector, raster. But the remote sensing, the hyperspectral sensors are in different formats. So to analyze that format, we need special software that is called NV. You can use that software, and you can generate results towards it. You can find some of the basic videos in YouTube, and how to use NV software, and you can use it on your own. I think it's much easier
Okay,
for
okay, sir.
candidate in PhD level. Yeah.
Yes, thank you so much, sir.
Thank you so much. Anything else?
I hope there is no more question today. And anyway, I think today's sessions was very useful for everyone, and we don't need to push much for asking question. So really nice. And Sharath, I think we have some quiz for the participants, right?
Yes.
So
Yes.
maybe we can do the quiz and wind up the session. And for your certificates, we will take 1.5 weeks to give all the certificates and the recording section. And we give you actually permission to download or record the today's session. So if you have already recorded the session, that is okay. But we will also share the link of our session. Okay, thank you. So this is a small quiz that we are prepared for each of you. You can just maybe scan the QR code and join the quiz. And you need two devices as I made before. One for seeing the question and one for answering the question. Okay, thank you.
Okay, thank you, sir.
I request everybody to click the link that has been given on the chat box to start the quiz. It's just the basic
I
thing.
think
Don't
three
worry.
of them already joined, and rest of the people can also join the session. And after everybody join, we will start the session. Is that right, Sharath?
Yeah, we'll just wait for 2 more minutes to.
Okay, please try to join by scanning the QR code or use the link that he had given.
The people who have joined already are requested to kindly wait for others to join so that we can start.
Hello, sir. Hello.
Yes, Saket.
Sir, actually, the question is not showing here.
Sorry.
Just scan now. Sorry, just scan.
Your voice is not clear. Like,
Sir,
text on the chat box, please. It's showing player limit reached. Okay. I think some technical glitch on it. Let's just start the quiz and you guys can guess the answer and uh, give it in the chat box and check your answers on the end of the quiz. I think it is the only go we can do now. Right, sir? We can start the quiz, right? It's showing player limit reached, sir. Okay, no problem. I think we'll just get started with the quiz. The people who have joined already, it's no problem. You just can guess the quiz answers and you can post on the chat box. If you don't know, no problem. Which satellite sensor is primarily used to obtain the sea surface temperature data from NOAA's post satellite? Options are MODIS, AVHRR, CWIPS, WIRS. Which satellite is primarily used to obtain the sea surface temperature from NOAA? It's a question. Options are MODIS, AVIRS, AVHRR, CVIPS, VIRS. The answer is AVHRR. Okay. Don't worry about the score and all. Just try to guess the answer. What is the approximate spatial resolution of AVHRR data used for ocean studies? What is the approximate spatial resolution of AVHRR data used for ocean studies? Options are 1 kilometer, 10 kilometer, 10 meter, 100 meter. Answer is 1 kilometer. Okay, the third question is the MODIS sensor on board NASA satellite Terra and Aqua gather data mainly in which spectral range? So, what is the spectral range of Terra and Aqua in MODIS? That is a basic question. Options are microwave radar, visible infrared, infrared and radio, UV and visible. The answer is visible and infrared. That's good. Next question is how often do Terra and Aqua satellite collect ocean images via MODIS? How often means it is about, the question is about temporal resolution. Every hour, twice a day, that is morning and afternoon, weekly, or once a month. The correct answer is twice a day, that is morning and evening. Terra will do morning and Aqua will do afternoon and vice versa. So twice a day is the correct answer. Which parameter can be used through satellite altimetry to monitor sea level variation? Which parameter can be measured through satellite altimetry to monitor sea level variation? Chlorophyll, salinity, temperature, or sea surface height? Sea surface height is the correct answer. Next question is what is the primary advantage of remote sensing for ocean studies? What is the primary advantage of remote sensing in ocean studies? Options are global coverage and uniform sampling, invisible data collection limited to shallow water only, and it is costly, slow, and data acquisition. The correct answer is global coverage and uniform sampling. It is the main advantage because ocean is very vast and the uniform sampling has to be done. So that is the main advantage of remote sensing over ocean studies. Which of the following is not one of the parameters identified from the measurement in seawater via remote sensing? So among these, which is not parameters identified for seawater? It's called water temperature at depth because satellite remote sensing only can assess the surface level parameters. Like even if it is temperature, it is only on sea surface temperature, not on the depth. Next question, which satellite sensor is particularly useful for monitoring ocean color and chlorophyll level? I think other than synthetic aperture radar, everything else. I mean, Landsat, MODIS, AVHRR, it is useful for chlorophyll levels. But MODIS is the primary thing where it is especially allotted to chlorophyll. What is the key challenge in remote sensing to assess the ocean color? What is the key challenge in remote sensing to assess the ocean color? Answer is atmospheric interference from aerosol and molecules. That's why we needed atmospheric correction. Next question, satellite altimetry measures the following to assess the ocean dynamics. The right answer is radar pulse return time to calculate the sea level. So radar altimetry is basically giving the incident pulse. That pulse will reach the sea surface and then it will get reflected back to the receiver on that particular sensor. So that time delay of that particular pulse to reach the sea surface and get back, that time delay will be converted into the distance from that satellite or sensor to the sea surface. That is the distance coverage. That is the main methodology of altimetry, satellite altimetry. Which orbit type is suitable for high resolution, small area observation? Which orbit type is suitable for high resolution, small area observation? Answer is low Earth orbit. Because when the satellite is on the low Earth orbit, of course it is very much nearer to the Earth surface. It can capture the land surface or ocean surface very clearly with high details, with high resolution as well. Why are the satellite preferred over ships for ocean monitoring? Of course, it is very easy. Why satellites are preferred over ships for ocean monitoring? The answer is they provide more frequent, uniform, large area data collection is the answer. Please don't mind the images that has been exhibited on the center of the monitor because it's automatic generated. I haven't posted. It's so funny to see that. Okay, next question. Which of the following is a major application of remote sensing in fisheries management? Major application of remote sensing in fisheries management. The answer is monitoring chlorophyll as a proxy of phytoplankton biomass. What is the main limitation of satellite remote sensing in ocean studies? Other than atmospheric interference, what is the basic limitation, main limitation of satellite remote sensing in ocean studies? We cannot measure these subsurface properties directly. Only the surface of the water body can be covered. Those parameters will be studied through satellite sensors, not the depth level. That is the main limitation. Which type of orbits allow the satellite to continuously observe the same location on the Earth? Basically, it is about the temporal resolution. Which type of orbit allows the satellite to continuously observe the same location on the Earth? The answer is geostationary orbit. Achha, the next question is, which satellite sensor is primarily used to measure chlorophyll content in ocean water? Again, I think the question is repeated, I guess. Yes, the correct answer is MODIS. Sea surface temperature is crucial in fisheries because Why SST is important in fisheries? Because it influences fish migration and spawning. Which of the following is a proxy for phytoplankton abundance? Of course, chlorophyll concentration. Let me skip this question. Thermal fronts in the ocean are significant because they are. Why the thermal fronts are very much important in ocean? Because it attracts the bait fish and predators. Which Indian satellite is equipped with OCM and MSMR sensors for ocean monitoring? Which Indian satellite is equipped with OCM and MSMR? OceanSat, which is on the program of IRS. What is the primary role of scatterometer in ocean remote sensing? Primary role of scatterometer. The primary role of scatterometer is to measure the surface wind, ocean surface wind. Which remote sensing technique is most effective for detecting the oil spill at night or in the cloudy condition? Because in daytime, oil spill detection is very much easy rather than in night and cloudy condition. To overcome that limitation, which technique can be used? Synthetic aperture radar. Synthetic aperture radar. If somebody have guessed the microwave radio meters, that is also correct answer, because synthetic aperture radar is also using the microwave band waves. Okay. Phycocyanin and microcystin detection in water quality monitoring is associated with which of the following? HABs. Which of the following is a primary indicator for upwelling zones in satellite imagery? Key indicator for upwelling zones. Cold SST and high chlorophyll. Of course, if you're guessing, because everything is important. SST is also important, chlorophyll is also important, and sea surface height is also important. But if it is the proportionality of high and low matters. Cold SST, that is low SST, sea surface temperature, and high chlorophyll pigment is the main indicator for upwelling zones, where the primary productivity of phytoplanktons will be high. The INCOIS PFZ adversaries using which two parameters to identify the fishing zones? Which two parameters? Sea surface temperature and chlorophyll. Which remote sensing platform is commonly used for coral bleaching detection? Among these, which program is used for coral bleaching? Sentinel-2. Sentinel-2 is comparatively high resolution, high spatial resolution, and high temporal resolution as well, because that's why it has been very much useful to real-time continuous monitoring of coral bleaching, especially in Lakshadweep, Andaman Nicobar, Gulf of Mannar, Park Straits. So I'm just covering the southern part of India, and in Gulf of Kutch, Kampat, and in Sundarban Delta, that is uh, the drains of Ganga and Brahmaputra Delta. So in that part also, some of the corals and mangroves are detected through Sentinel-2 data, and it has been monitored continuously. So 3 more questions. ARIMA models in the fisheries forecasting are used for what? Predict fish production trend. And the trend is not just for the historical data, but it establishes the future prediction as well. Which sensor type is best suited for bathymetrical mapping in shallow water? Which is useful for bathymetric mapping in shallow water? Yes, it is LIDAR. Which phenomena is characterized by abnormal warming of Central or Eastern Pacific Ocean? Answer is El Nino. Final question. What is the main advantage of remote sensing in fishery management? I think this is also repeating, I guess. To enhance the fishing and sustainability. That is the main advantage of remote sensing in fishery management. Yes, it is the most direct question I have ever seen. Okay. Congratulations to all the good guessers, not just the one who have joined the quiz online, but also who have guessed on the chat box or in your just in the Gmeet, sorry, Zoom meeting. I think we can wind up the session. It's too late. It's almost 10.
Okay, thank you so much, Sharath, for today's session. As you said, it is going to be 10 in India. So maybe we can finish today's sessions, and please keep in touch. And if you need any special sessions, let us know. And we will provide you the certificate within 1.5 days or 10 days. Okay, in next 10 days. Good night. Have a great day. And keep in touch. And the PPTs will be shared in your mail. Okay, and don't share with others. This is exclusively for you, people who paid and joined for our session. Thank you.